Welcome back. We are coming back from the previous episode when we spoke about JDK, GRE, and Java Virtual Machine. We had an overview of a compiler, so at this moment we are going to start to reveal what's compiler, what's bytecode, what's a class file. Let's get into the presentation. Java is a command which used to execute your Java class file and turn it into bytecode. So let's get into compiler. Compiler is a software written in Java to convert the Java file to bytecode, intermediate machine independent, which later on you can transport this file and use it anywhere on any operation system, and it will run by the Java virtual machine installed in that operation system. Java provides also more options to compile your files and the way you need it, such as changing file directories, debugging code, and a lot more functionality. If you would like to reveal all of them, you can use in your command line this command java --help. You will find on your command line all the information that you need to know about how to use Java in your local machine. Most of Java compilers didn't optimize the code, leaving it to the Java virtual machine to do it. Depends on how the Java virtual machine and the compilers used. But there are some compilers which output optimized native code for specific hardware or operation system, such as GNU compiler for Java. So there are several types of Java compiler, for open source, from Oracle or from Eclipse. So you can find a lot of them. If you make a Google search, you will find the list of Java compilers and which one to use and where to use if you would like. Java bytecode. What is the bytecode exactly? Bytecode is the output of Java compiler. When you compile your source code, you are converting this source code into another type of file or a set of portable instruction, P code. It's not human readable because it's made especially for efficient execution by interpreting them or compiling them to the specific operation system at runtime by the Java virtual machine. So the bytecode is the intermediate file which you create as a .class file, so later on has all these instructions for virtual machine to start execute your application. The bytecode is a compact numeric code, constants and references, normally these numeric addresses, that encode the result of compiler parsing and performing semantic analysis of things like type, scope, and nesting depths of program object. In the next chapter, we are going to reveal what is this constants, what is references, what is the bytecode exactly, and what is the class content after the compiler producing it. Class file structure. File of class structure is a compiled class file consists of the following structure, such as U for magic. The magic ID is a number identifying the class file format. It has this value as you can see it on a screen for each kind of application or each file produced for the virtual machine or for the operation system to know exactly what this file about and which program is used to execute this file. Each file has a magic number. You can say like the extension. For example, for image file there is specific magic number, for Java file there is specific magic number, for audio files, for video files. So each file type has its own fixed magic number. After that we have minor version. Minor version is the number of a class file format being used, which JDK wrote this file. We have major version as well. It's the same indicator of which JDK wrote this file structure. We have a constant pool count. Constant pool is a number of entries in the constant pool tables plus one. As you know, in a Java class, sometimes you declare a few constants for reusable. You can use it in the same class or maybe another one. So each class has its own constant pool. So you can know exactly how many constants you have in this class. Then after you have the constant pool count, you'll have the value of this count, the information about where these constants are stored. Constant pool info is a table of structure representing various string constants, class or interfaces names, field names sometimes, and other constants that are referred to within the class file structure and its substructure. So the file which you use, the file or the class, it already contains some constants. You will have a count of how many constants you have, and then you have another information about where this constants is stored on your runtime environment. Going to access flag. Each class has its own access flag. You can make it private, public, default, or package. So it is up to you to decide the visibility of your class. That's why the class it will have information about its own access flag. We have this class. This class is index in the constant pool, providing the fully qualified name of this class. You can get the class by class name as well, and this name is stored in a constant pool, and when you use the word this inside your class, it's automatically referred to the class name of your user. That's the purpose of using this dot operator inside your class. Superclass. It's zero or must be a valid index into the constant pool table. Sometimes your class is going to be inherited from another class, so your class is a child of another class. In Java, object is the parent class of everything we use in Java. Then we have interfaces count. If your class implementing several interfaces, so you will have the count how many interfaces your class already implemented. As you know, Java has multiple implementation of multiple interfaces but single inheritance only. Interfaces count. Each value in the interface array must be a valid index into the constant pool table. The constant pool table will have a reference which interface you are implementing in your class. Then we have fields count. How many fields you have in your class? We have this fields info. It's a structure giving complete description of a field in this class or interface, included only those fields that are declared by this class or interface. Another one, methods count. How many methods you do have in your class or your interface, and also the information about these methods, like method argument structure, giving a complete description of a method in this class or interface for later use. Represent all methods declared by this class or interface type, including instance methods, class methods, instance initialization methods, and any class or interface initialization methods. Continuing with attribute count. How many attributes you do have in your class? And also another one will be the attribute information, references to these attributes, or if you are using annotation over your class, which using retention policy.class or retention policy.runtime. Usually, this is our Java class file structure. Each single class, it will have the identical field, but with a different values, depends on the class position in your application and depends on the use of this class. That will take us after to what is Java architecture in more details, what is Java virtual machine architecture, what is the workflow of Java virtual machine. That's going to be our next episode. Thank you so much for your listening and your time. See you next time. Bye bye.